This is an electric motor. It has a pivot, a point about which it turns, and thanks to the interaction between the magnetic field lines in a magnet and the concentric field lines around a conducting wire, you get a total resultant force in a particular motion. And thanks to this pivoted setup, then that motion is a spin, okay, which enables the spinning then to be applied to a million different uses. So what we're going to look at is this particular section here, which is called the commutator. Why do we need a split ring commutator? Let's use the left-hand rule to look at this specific side here. We have current moving in this direction. We have a magnetic field pointing towards the south. And so if you use Fleming's left-hand rule, you should be able to tell that the force is down. Stop the video and check that that's indeed the case. Now, this works because the positive terminal here is connected to the wire. As the wire spins round to the other side, however, if it happened to be still connected to the positive terminal, then nothing would change. And if you applied your left-hand rule, you would find that the force was down on this side, even though that means that it would no longer spin. In order for it to work, the wire which is carrying current in this direction needs to somehow disconnect from this side and connect to the negative terminal when it's on this side here. Why? Because we do not want the current flowing this way, because that would create a force downwards. We want somehow the current to flow in this direction. And that's why this disconnection needs to happen. While it's connected to the positive terminal, along this wire, you will have the current flowing in this direction. When it's on the other side, it disconnects and connects to the negative terminal. And so therefore, using the left-hand rule, you can see that the force is now up. In this way, when it's on this side, the motor feels a force down, making it spin around. And then when it gets to this side, because it's disconnected and connected again to the negative, it now feels a force up, which makes it continue spinning. And again, as it turns round, it disconnects and connects to the positive terminal again, and again feels a force down. So this will make it continuously spin in a circle. Have a think about what would happen if we didn't have this disconnection, if this wire was always connected to the positive, regardless of what it did. If there wasn't this disconnection, what would happen is that the coil would spin round, get to the other side, and then come back. And they backwards and forwards in this direction continuously. It wouldn't have any smooth circular movement, which is pretty pointless for a motor. So that's what the split ring commutator does. It's a gap which allows the coil to disconnect from the positive and the negative terminals, switching polarities, that's one way of saying it, polarity, so that you can keep the force in such a way to make the coil spin.